So I guess I'll start with your concern and do a synthetic division one and show you how it works. So for example, synthetic division. Let's take 2x to the fourth minus 3x cubed plus x minus 5 and divide this by x plus 2. I don't know what the answer is, but it'll come out. First thing is you take the dividend. I always forget what the names of these are. Divisor, dividend, quotient, remainder. So we're going to take the dividend and write out the place value of it. So it's 2. I'll give you that much. Next number? Negative 3. Next number? 0, because we're missing the power of x squared. So it's 0x squared. 1 for the x, and negative 5. And then we're going to divide by the x plus 2, but to take care of the subtraction, you change the sign of it. So it becomes minus 2. So you put minus 2 here. Draw a line leaving the space between the top line and the bottom line. And it becomes simple after that. Drop the 2. That always happens. Negative 2 times 2 is negative 4. Negative 3 minus 4 is negative 7. Negative 2 times negative 7 is 14. 14 plus 0, of course, is 14. Negative 2 times 14 is negative 28. Plus that 1 is negative 27. Negative 2 times 27, 54. Positive. So this would be 54, and therefore the remainder is 49. Now when you take the answer out of this, you have to go back into place value. This is the units. This is x. This is x squared, and this is x cubed. That last number is the remainder, so you just want to leave it off. So this becomes 2x cubed minus 7x squared plus 14x minus 27 plus, and then you put your fraction here. 49 is your remainder divided by x plus 2. That's all there is. It's an easy technique. All it is multiplication and addition. All right. Any other lingering doubts about anything? Good. We can go on. Morning, gentlemen. One of these days you'll come here before 8 o'clock.
I did.
When? It's 8:02.
Hey, see, it took you 2 minutes to finish that.
The sad thing is my watch is 2 minutes behind.
My watch 2 minutes, 4 minutes slow.
Say that again?
My phone is 6:59.
What is this, 5, I think? Not binomial, trinomial. 5, 5. Yeah. So 5, 5. Factoring trinomials. I started this the other day talking about the general polynomial and the 2 cases that we're going to deal with. Let's refresh it. If we have ax squared plus bx plus c, this is our general quadratic. It's called a general quadratic, or general polynomial of degree 2. And we were talking about how to factor this, and there's 2 possible ways of factoring it. There is the case where a is equal to 1, and there is the case where a is not equal to 1. And how we're going to treat them differently. Today we're going to deal with the case a equal to 1, and maybe at the end of the class we'll deal with one that is not equal to 1. And I'll show you how they're done similarly, but there is a shortcut to the first one. So where does this factoring come from? Well, to get something that looks like ax squared plus bx plus c, where a is equal to 1, you're going to multiply together 2 binomials, where the lead coefficient of each one of the binomials is just x, because x times x would give us 1x squared. All right, what goes in the second position really doesn't matter. It could be any numbers, 2 and -3, 5 and -7, it really could care less. So I'm going to call it capital A and capital B. Now, before I multiply this all together, I have to ask you a question. When I take 5x and I add 7x to it, what's it equal to? 12x. Why? In other words, what property? Distributive. You kick out the x, and you leave behind the 5 and the 7. So we're going to use that technique with this because we can't exactly add two numbers together because one of them is a and the other one is b. So x times x is x squared. X times b is positive bx. Positive a times x is positive ax. And then finally, a times b is a positive ab. Now, obviously, a and b don't have to be positive. They could be positive and or negative, but this gets the generalities out of the way. Can I combine the two middle terms? Yeah. What property? Distributive. This is how much their short-term memory doesn't even work very well. So we get x squared. What are we going to kick out? X. What's left behind?
A plus B.
We can write it a plus b by using the commutative property. So a plus b. And this is positive. And then at the end we have this plus ab. So the trick is going to be this. It's going to be these a plus b and this a times b, since it's in both the middle term and the end term. Now, here's the weirder question. Which one is more unique? Numbers that add up to a specific number, or numbers that multiply to a specific number? Which one's more unique? I'll give you a hint. What two numbers add up to 6? 3 and 3. What else? 2 and 4. 5 and 1. 6 and 0. That's it. Positive 7 and negative 1. Positive 8 and negative 2. Positive 9 and negative 3. How far can I go? A long way, infinity. So this isn't very unique. Now, if I come over here and I say, what are factors of 6? What are they? 2 and 3. 1 and 6. And that's it. Very unique at the end. So our technique is going to be based on this last number. We're going to say factors of this last number. A lot of people skip this part, but be really careful. That plus sign means add. You're going to take the two factors and you're going to add them. If that sign is minus, you're going to take the two factors and subtract them, and that's really important. A lot of people skip that, and then they pick the wrong two numbers. And we want it to add up to, obviously, a plus b. So let me give you a simple example, which also happens to be one of the trickiest examples, which is kind of weird. X squared plus 5x plus 6. And I want to factor this. So it starts off with, you look at the last number. So number 1. Factors of 6. And then secondly, you look at just the sign of it. And this one will be number 2. And number 2 will say, add that, add up to. And then finally, you concentrate on the coefficient of the middle variable. It's a positive 5. So this would be number 3. And this would be 5, positive 5. So if you read this correctly every single time, it's very hard to make a mistake in how to factor this. So it's factors of 6 that add up to positive 5. So basically it's reading opposite direction that you're used to. What the heck? Stupid windows. And then this is what we're going to do. We're literally going to undo what I did over here with the A and the B. Right now we found that the two factors, eventually we'll find them, and then we're going to split it into two pieces, the AX and the BX. So what are factors of 6 that add up to 5? 2 and 3. So we're going to take this middle term, this 5x, and we're going to expand it out. We're going to leave the x squared alone. The 5x we're going to write as 2 and 3. But if I want them to add up to 5x, they both also have to have a x. So this will be 2x and 3x. Now the signs are important because we want it to add up to a positive 5. So what do both of them have to have? Plus. So we're going to get plus 2x, plus 3x, and then finally that plus 6. So this is what's called an expansion of a polynomial, where you're breaking apart one of the terms into two that you want to work with. Okay. After you do this, how many terms do we have? 4. And how do you factor in something with 4 terms? Group them. So we're going to group the first two and yank out the greatest common factor. What's the greatest common factor between x squared and 2x? X. So you kick out the x, what's left behind? X plus 2. In the second two, you have to be careful. Remember, you have to pop out a sign also. So it's either positive something or negative something. In this case, it's going to be positive 3. So that plus sign goes here, 3. What's left behind? X plus 2. All right, now we're down to 2 terms. What do they have in common? The x plus 2. So I'm going to kick out x plus 2. Remember, when you kick it out, you're actually dividing it out. So the first term divided by x plus 2 leaves behind x. The second term, when you get rid of the x plus 2, you're left with a positive 3. And there it is, factored. So it's not a hard process. And as you do more of them, you start seeing what the shortcut is, because I'm not going to show you the shortcut. You have to figure that one out on your own. But you'll see it pretty quickly. But then the danger becomes when a is not equal to 1, you try to use the shortcut and you get them all wrong. Because the shortcut only works if that lead coefficient here is 1. It's the only time it'll work. All right, so let's try a couple of these. Steal some out of the book. How about this one? Another simple one. X squared plus 12x plus 11. Now remember, the language, the sentence that you want to read to yourself so you don't pick up the wrong numbers is going to be backwards. So it's factors of 11 that add up to a positive 12. And you want to make sure you get that add, because that'll tell you pretty much what numbers you want to deal with. So what are factors of 11 that add up to 12? Which one? 1 and 11. So we're going to separate this into 1x and 11x. What kind of signs are they going to get? Both positive. This is, again, a simplistic one. You kick out the x squared to the front, and that positive 11 just drops down in the back. Now, does it matter what order we put the 1 and 11 in? Why? Well, what property can I use to switch them? Commutative. And since it's commutative property, it shouldn't change the answers. Now, it'll change some of the steps, but the final answer should be exactly the same. All right, it's down to 4 terms. Group and factor. GCF of the first two? X. Left behind is? X plus 1. GCF of the second two? Plus 11. Make sure you get that operation in there. And left behind is? X plus 1. And then you can kick out x plus 1 and leave behind x plus 11. And there you are. And if you want to check your work, it's not that hard. You just multiply it back out. Here's x squared, here's 11x, here's 1x, and there's 11. And 1x plus 11x is 12x. So if you multiply it back together, it should give you the original problem. Not that bad. Let's find one that's worse. This one. X squared minus xy minus 56 y squared. Right? Now don't let that y squared throw you, because this process will work whether it has just x's or a mixture of x's and y's or a mixture of any variables. So you start here at the end. You don't care about the y squared. All you care about is this negative 56. Actually, you only care about the 56. So you start off with factors of 56. The next sign is that negative, so you're going to subtract. What is the difference between adding and subtracting? How do you add numbers? What has to be true? Not like terms. If I give you -3 plus a -2, are you adding them or subtracting them? You're adding them. They have to have the same sign. Now, if you're subtracting, what has to be true? There are opposite signs. One's positive and one's negative. So once you get to the subtraction part, you know one's positive and the other one is going to be negative, guaranteed without a doubt. And then what do we want it to subtract up to? A -1. So you got to, remember that 1 is there by the identity property. So we're looking for factors of 56 that subtract up to -1. 8 and 7. So we're going to split this xy, negative xy, into an 8 and a 7. What kind of 7? Positive. What kind of 8? What else has to be put in there? An xy, because we need these two to add together to give us this negative, or subtract, to give us that negative xy. So they both have to have the xy. And then just bring down the front and bring down the back. So the front is x squared. The back is -56y squared. Don't drop off that y squared. You need it. All right, and then the process starts all over again. Group the first two. What do they have in common? X. What's left behind? X minus 8y. And if I group the second two together, what can I pull out?
Y.
Well, y and a 7 and positive. If it leads with a positive, you're going to yank out a positive. So positive 7y. Left behind? X minus 8y. Now, you know you did it right when these two are exactly, and I mean everything about them is exactly the same. They both have a minus, they both have an x, they both have an 8y. Yank these two out front, and you get x minus 8y. What's left behind after I divide it away? X plus 7y. And there you are. Nice and factored. Not that bad, right? With a little practice, you can do these fairly quickly. And you're going to need to, because when we get to chapter 6, one problem you'll have to factor like 4 or 5 different things.
How you get that 7y on this side? The x plus 7y.
Over here?
Uh-huh.
Well, when you pull this piece away and you pull this piece away and you put it out front, remember factoring is you pull out the common factor.
Mm-hmm.
So the common factor here is x minus 8y.
Oh, I see.
And when you divide it away, you're left with this x and this 7y.
Okay.
Yeah. How about this one? X to the 4th minus 6x squared minus 55. Not exactly the one I wanted, but we'll go with it. Perfect. You just leave it in my box, sir. People student services. All right. Start all over again. Factors of 55 that subtract up to -6. Make sure you get that sign in there too. You need to know what it is. So what are factors of 55 that subtract up to -6? 5 and 11. So 11, 5. What do they both? Oh, actually no. Hold on. I want to do this backwards for some reason. Let's do 5 and 11. 5, 11. What kind of 5? What kind of 11? Positive 5, negative 11. What variable do they both get? X squared. This is the middle coefficient is x squared, or variable is x squared. So they both have to have it. Because when I add those two together, I need them to add up to, subtract up to -6x squared. All right, bring down the x to the fourth to the front. Bring down the negative 55 to the back. Oh, I swear. And then group and factor. GCF of the first two. X squared, left behind. X squared plus 5. GCF of the second two. Negative 11. When it leads off with a negative, you have to yank out that negative portion. So negative 11, left behind, x squared. And just remember, it's negative 55 divided by negative 11. That'll give you the correct sign, which is plus, and that'll be 5. Don't copy this down just because you know it's the first one and you know it should be the second one. If you do that, sometimes you're going to make a mistake because you picked the wrong numbers to begin with. There is a possibility that two numbers subtract up to the middle number and two numbers also add up to the middle number. For example, 6. Give me factors of 6 that add up to 5. 3 and 2. Give me factors of 6 that subtract up to 5. 6 and 1. And you have to be kind of careful with some problems because they have that duality to them. And if you pick the wrong one, your answer is going to come up wrong. And the way to check that is, like, for instance, if we chose 6 and 1 and we were supposed to choose 2 and 3, what will happen is one of these will be positive and the other one will be negative. It'll be opposite signed and you'll know you picked the wrong numbers. So don't just go copying it down twice because sometimes you'll be copying down the wrong thing. All right, what's the GCF of those two? X squared plus 5. And left behind? X squared minus 11. And that's it. Kind of a neat idea. Again, there is a shortcut if you want to find it, but just be cautious that the shortcut does not work in the next case. All right, the next case. Or do you want to try one? Oh, let's make you try one. Oh, what looks good? There's one. X squared minus 10x plus 24. Factor. One minute. I won't stop trying to jump into the answer.
So I get wrong numbers.
4 wrong signs.
Because they got two wrongs.
Don't I make it look so easy? And most of you, half of you have picked either wrong numbers or wrong signs.
Which one I do?
I don't know. You'll find out in a second. Wrong numbers or wrong signs will kill you because when you get down to that second grouping and they don't match, you have a clue that you did something wrong. Alright? Yeah, it doesn't seem to be working, does it? So therefore you either pick the wrong number or the wrong signs. That's what I like about this method because it's self-checking. Did you get it? What, did you do guess and check? Oh, good. Guess and check is good for some, not all. Let me give you a hint. What are factors of 24 that add up to 10? 6 and 4. What are factors of 24 that subtract up to 10? 12 and 2. But which one are you supposed to be doing? Adding or subtracting? Adding. So you have to pick 6 and 4. There is no option here. Ah, because you did this. When you split this 10 up into 6 and 4, what signs do they both have to have? Negative. You chose one to be positive and the other one to be negative. They both have to be negative because you need these two numbers to add up to negative 10. All right, and they both get a x. You get this 24. You bring down the x squared. You can't just rush ahead with these things. You have to check yourself at every step to make sure you're picking the right stuff. And then when you pull out the GCF of the first two, you get yank out x. Left behind is x minus 6. When you pull the second two, you have to pull out a negative 4, and left behind is x minus 6. And then finally, pull out the x minus 6, leave behind x minus 4. So it's not just picking numbers that do what you want them to do. You have to pick numbers that do what this problem wants you to do. So it's not your choice, it's the problem's choice, actually. All right. So what happens if the lead coefficient is not 1? When that a is not equal to 1. Well, things get a little messier. And I'm not going to show you the product of the two binomials that come up with the possibility that a is not equal to 1. It really just gets messy, so I'm just going to show you the technique that actually is going to work. So for instance, something simple. This one. 3x squared plus x minus 2. Now, when you cannot remove that factor of 3 from the front, this is the technique you need to use. What happens is, instead of just concentrating on the last number to find out what the middle number is, this 3 introduces more factors that you have to work with. So you need to take the coefficient 3, and you have to multiply it by the end number, which is 2. And 3 times 2 in this case is 6. So the number we're working with is really going to be that 6. So that's where we're going to start our sentence. Factors of 6, and then we hit the minus sign, that subtract up to 1. So what are factors of 6 that subtract up to 1? 3 and 2. So we're going to write 3, 2. What kind of 3, what kind of 2? Positive 3, negative 2, because we want these to subtract up to a positive 1. What variable do they get attached to them? X for both. So it's positive 3x, negative 2x. And drop down that first term. Now don't be dropping down x squared, because that's not what it is. It's 3x squared. So drop down 3x squared, and drop down that negative 2 at the very end. And then it turns into the same process. So not much has changed other than you multiply the first number times the last number. By the way, that technique works on the ones that have lead coefficients of 1. 1 times 24 is 24, factors of 24 that add up to, and so forth and so on. So what's the GCF of the first two? 3x. Left behind? X plus 1, because 3x divided by 3x is 1. Remember, factoring out is the same thing as dividing away. GCF of the second two? Negative 2. Give it a sign. When you divide it away, you're going to get x. Negative 2 divided by negative 2 is a positive 1. And then those two binomial pieces become exactly the same. What can I pull out? X plus 1. What's left behind? 3x minus 2. And you're done. And if you want, you can multiply that out, FOIL it out, and see if it's right. So there is a way of checking these things to make sure you're always getting them right.
How you check them?
Just multiply back together.
Okay.
3x times x is 3x squared. X times negative 2 is negative 2x. 1 times 3x is 3x. 3x minus 2x is 1x. And then finally, 1 times negative 2 is negative 2. So you should never have a wrong factoring because you should always be able to get the right answer, or at least know you got the right answer. All right, do they get harder? Yeah. Bless you. How about this one? 5x squared minus 13x minus 28. This one's not very friendly. So you start off by multiplying the first coefficient times the last number. So the 5 times this 28 down here at the end. Let's see, 5 times 28 is, what is it? 140. So we're looking for factors of 140. Now, if it's a nice easy one, like if it was 4 in the middle, then I would choose 14 and 10. That would make perfect sense. But it's 13, and I don't know factors of 140 very well. So here's another technique you can use. You take the 140 off to the side, and you break it down into its possible factors. Two numbers that multiply together to give you 140. And if you're systematic about it, eventually you'll get to the right answer. So 1 times 140, 2 times 70, 3 times, does it work? No, so don't even worry about 3. 4 times, 4 times what? 35. 5 times 28. 6, does 6 go into it? No, 6 doesn't go into it because 3 didn't. 7 and 20. Hey, 20 minus 7 is 13. So this is the one we want. Also, this method has another possibility. If that number, if we went through this whole list of all the possible factors of 140, and not one of them subtracted up to 13, then we could say that this thing is prime. Now, do they do that in here? No, not yet. So we'll deal with that later. So we know our numbers are 7 and 20. So let's see here. 7, 20. What kind of 7, what kind of 20? Positive 7, negative 20. And they both get the x. And then bring down that first term, which is 5x squared. Bring down the last term, which is negative 28. And then we can start our technique. GCF of the first two terms. X. What's left behind? 5x plus 7. GCF of the second two terms. Negative 4. And left behind is 5x. And negative 28 divided by negative 4 is positive 7. And then we have common terms we can pull out. That 5x plus 7. What's left behind? X minus 4. We're done. So the process takes a little bit of writing, but it generally doesn't take up a lot of time. It's pretty quick once you get those two factors. All right, your turn. I'll try to pick something nice.
Not that one.
We did that one. That's not too bad. 6x squared minus 7x minus 5. Try that. At least you're all picking the right numbers this time. So let's see. Factors of the 6 times this 5 way down here, of course, is 30. What are factors of 30 that subtract up to negative 7? 3 and 10.
Oh, okay, thank God.
The easy two. It's always the easy ones that throw you. What kind of 3, what kind of 10? Positive 3, negative 10. They both get the x. And then you get a negative 5 at the end and a positive 6x squared at the beginning. And then it works out perfectly fine after that. GCF of the first 2 terms. 3x. Left behind is 2x plus 1. GCF of the second 2 terms. Negative 5. And left behind, of course, is 2x plus 1, because negative 5 divided by negative 5 is a positive 1. So finally, write it up here. We pull out the 2x plus 1, and we leave behind 3x minus 5. Now, you have to be careful. What's that?
Uh-huh.
I got the same thing, you did it a different way.
You put the 3 and the 10 in different positions.
Mhm.
Oh, that might have been it.
Yeah, once you commute them, the work underneath changes until you get to that last step. And that last step, your answer is just going to be 3x minus 5 times 2x plus 1, because you commuted to begin with. Which is kind of cool if you think about it, because you're commuting addition, and it results in the commuting of multiplication, which is kind of neat. All right, so the only way to get really good at this, of course, is a lot of practice. So you're going to get a ton of homework tonight about factoring. And I really want you to do every single problem that you can do. The more you do, the better you get at this. The better you get at this, the easier it comes, and the test you should be able to, just fly right through. So when do these things become hard? They don't. That's the beauty of them. Well, I could pick bigger numbers that would be harder to find products of that add up or subtract to a specific number. But technically, I can't make it any much harder than that. So what I'm going to do now is take apart. I don't like 5, 6 in this book. It talks about special factoring. I don't like talking about special factoring. I just rather do it all exactly the same. So there's a portion in here. This is 5, 6, just a part of it. They talk about perfect square factoring. And I'd rather you not learn the perfect square factoring setup. I'd rather you just factor it the way I showed you in 5.5. Because there is no point in memorizing one method for one type of trinomial and another method for a special type of trinomial. The only reason you would want the special one is if you want to factor it like almost instantly. And I'd rather you not memorize stuff. I'd rather you just be able to do it and get the right answer. So the problems don't change, really. They're still trinomials. So like, for example, 16y squared minus 8y plus 1. So I'd really rather you not do this the book style. I'd rather you look at this and say, oh, I need to factor a trinomial. What's the first step? How do you factor this? Multiply the first term, which is 16, and you're going to multiply it by this last term, which is 1. So 16 times 1, of course, is 16. So that's the number we're going to work with. What are factors of 16 that add up to 8? 4 and 4. So when we split this up, it's going to be 4y and 4y, which is a little strange because we're used to working with different numbers, and these are exactly the same. Now, you have to be careful. You can't make one plus and one minus because that adds up to 0. And obviously, there's a negative 8y here. So they both have to be negative. And then bring down your plus 1 and bring down your 16y squared. I see no point in memorizing any silly formula in the book, because this works out just perfectly fine. GCF of the first 2? 4y. Left behind, of course, is?
2.
Careful. 16 divided by 4?
4.
Just wrote 2 things. Got a 2 in my head. 16 divided by 4 is 4. And then you're left behind with a y. Minus 1. GCF of the second 2? Negative 1. If you can't pull out anything at least pull out a 1. In this case, it would be -1. Left behind, 4y minus 1. And then you can just pull out front what's in common. Well, what's in common? 4y minus 1. What's left behind? 4y minus 1. And since they're the exact same factor, I can simplify this and write it as 4y minus 1 squared. So it's a perfect square factor, which is kind of cool.
Basically, it's gonna be the same factor with either.
What's that?
It's gonna be the same thing with either. Factor.
Oh, if it's a perfect square one, yeah, they're going to be identical. Once you get these two numbers exactly the same in the middle, you know it's a perfect square. But don't jump ahead. And if you want to memorize the formula in the book, great, but I don't see any point in it. I think it takes up too much space in your brains to bother with. All right, here's one for you. Let's see if I can find a good one. Ooh, that's a good one. 64x squared plus 48xy plus 9y squared. Yeah, I would say that. Maybe I should show you another little technique on this one. Now, what's 64 times 9?
A number.
A number, yeah, a number. Which one?
576.
576. Now you have a choice. You can go off to the side and go 1 times 576, 2 times whatever the heck it is. Or you can use a little recognition. There is another little technique you can use. And this technique is kind of neat. 64 can be broken up into what? 8s, right? 8 and 8. 9 can be broken up into what? 3 and 3. What happens when you multiply the first number times the last number? You're taking all their factors and mixing them together. So to unmix them, you can match these up. What's 8 times 3? And the other 8 times 3? And if you look at it, 24 plus 24 is 48. It's another way of breaking apart large numbers. You could do it over here too. 16 was 4 and 4, 1 is 1 and 1, and you get 4 and 4. So it works all the time, even if they're not perfect squares. This is a nice little technique to play around with. All right, so I'm going to choose 24 and 24. What do they both get? Both of them are plus. What else do they get? At xy. All right, bring down the first term, which is 64x squared. Bring down the last term, which is positive 9y squared. And then the technique takes over. GCF of the first two. What is it? 8x. Left behind. 8x plus 3y. All right. GCF of the second two.
3y.
Careful. I'll give you the 3, I'll give you the y, but you better say plus. You need an operation here. So plus 3y. Left behind? 8x plus 3y. And then you yank it out front. So you get 8x plus 3y. Left behind? So I might as well just write squared. Because it happens twice. Mix and match factors.
So that instead of multiplying the 64 and 9, you just
Break them apart and then just work it with the pieces. Now you can use the same technique with some problems in 5-5. Do they have an ugly one? Let's see a real ugly one. No, they keep it good. Nice. They don't care. Oh well. One last problem. Just to throw your techniques out the window for a second. How about this one? 60b x squared minus 84bx minus 72b. That's a lot of junk. Now, all of the problems up to this point, I've just been showing you how to factor a trinomial. This one changes just slightly. It's still a trinomial, but if you try to tackle it the way we've been doing the other ones, you're not going to get any good answers out of it. So, what I have to go back to is, what is the first step of factoring? Y'all forgot. The first step of factoring is the first type of factoring I showed you. What was the first type of factoring I showed you? No, before grouping.
Comment. Find something common.
Find something common.
See, I was gonna say.
Is there anything in common between all three of these terms? Yeah, what? B
12.
and 12. B12 sounds like a vitamin. So we're going to kick out 12b even before we start this problem. So a little hint. The first step of factoring is always pull out the greatest common factor. It does two things. It makes things look a lot nicer, and it makes the numbers a little bit smaller. Plus, you don't have to deal with this 12b anymore, and it just pulls down as part of your answer. So if I pull out a 12b, what's left behind? Well, 60 divided by 12 is 5. The b is gone. What's left behind is that x squared. Minus 84 divided by 12? 7. The b is gone, and left behind is this x. Negative 72 divided by 12 is negative 6, and the b is gone. So what's left behind is actually kind of nice. The numbers are a lot smaller, and it looks a lot neater. But don't stop there. Just because you pulled out the GCF doesn't mean you are done. It's got a trinomial in it. You have to try to completely factor this. You want to break it apart into all its little small pieces. So on the inside, we have to take the 5, and we have to multiply it by 6, which gives us 30. So what are factors of 30? That subtract up to negative 7. I was waiting for it. Ms. Richardson. Factors of 30 that subtract up to 7.
10 and 3.
Yay! Remember that from earlier? No.
Yeah.
So this is 10. Miss Barker's dying. 10 what? 10x, and it's going to be negative, and a positive 3x. Don't forget the negative 6, and don't forget to bring down the 5x squared. Do I have to put that 12b up front? Technically, yes, but I don't want to get it in my way. So what you have to do is you have to remember to bring this piece down into your answer when you're done. It's just going to fall right down in front of it. So GCF of the first two, 5x. Left behind, of course, is x minus 2. GCF of the second two?
3.
Plus 3. And left behind? X minus 2. You really need that sign. I've had people write it as parentheses 3. And what that means is multiplication, not addition or subtraction. So make sure you get an operation in here. Kick out the x minus 2. Left behind is 5x plus 3. And then don't forget to bring down that 12b. So this is your final solution. So if there is a greatest common factor, you do still have to kick it out before you can finish factoring up the problem.